Hello, class. Welcome back to the third lecture in the series of forces and winds that we have going on. This will be the last one. So let's get started. All right, so in this lecture, we're going to be going over winds aloft versus at the surface because they actually don't interact the same. We're going to go over another balance called geostrophic balance, how we determine the wind direction, and also high and low pressure systems in the winds. So now winds around lows and highs aloft. We went over this a little bit. I think previous did this. They do go clockwise around a high, and they go counterclockwise around a low. All right. This is called a counterclockwise. This is called cyclonic flow. Or clockwise, this is going to be anticyclonic flow. So what actually happens is your air parcel is going to come along. Okay, and it's going to get pulled towards the low pressure because of pressure gradient force. Because all wind systems, all air is actually going to go from high to low pressure, so it's going to be coming along. It's going to encounter the pressure gradient force, and it's going to start getting deflected here to the left on a low pressure system, or to the right on a high pressure system, depending on which one you're looking at. Okay, and then what's going to kick in is the Coriolis force, actually separate from that. So remember, the Coriolis force actually is the thing that's going to deflect things in the upper, or the, let's see, to the right in the northern hemisphere, and to the left in the southern hemisphere, right? So it's deflecting to the left here, and it's deflecting to the right. And remember, we said with respect to the wind, oops, right? Because it's actually going, this is the wind right here, where this is the wind over here in a low pressure system. So, what's going to happen actually is these two forces are going to balance each other out. So we're going to have the Coriolis force and the pressure gradient force be in balance. This balance is called geostrophic balance. Now, this is important to know that the winds are in geostrophic balance aloft. All right, at the surface is a little bit different because there's another force that kicks in. But at aloft, we're going to have a balance between the Coriolis force and the pressure gradient force. So what that means is that the air is going to flow parallel, or the wind is going to flow parallel to the isobars. So here's our isobars right here. Here's our wind, and it's just going to go parallel to the isobars. Okay? Now, the reason why it's different aloft than it is actually at the surface is because friction is going to be assumed to be zero aloft. There isn't going to be any friction, where at the surface we'll have friction. All right, and remember I was telling you that when the lines were closer together, that the force was stronger? Okay, so this is going to kind of give you a little bit more of an explanation to that, and also explain to you how how they're equal and opposite. So if we have a river coming along, and it's got the banks, you can see them kind of further apart here, and that it encounters an area that's more narrow than it is, where it first was, then it's actually going to become a faster flow. So it's kind of like when you put your finger over the nozzle, or a garden hose, you're going to actually increase the pressure because you're giving it less room to actually move through. And the wind is going to act the same exact way. It's going to be coming along. It's going to have, less pressure, and it's going to be coming along. It's going to encounter an area that has, where those isobars get closer together, and it's going to encounter more pressure. So that means that the pressure gradient force is actually going to be stronger. But because the wind, that force that causes the wind to speed up, then what's going to happen is the Coriolis force is going to get stronger, and it's still going to counteract it. So it doesn't matter, how weak or strong the pressure gradient force is, that Coriolis force is always going to kick in and be an equal and opposite balance to it, which is why in the upper atmosphere, the flow is constantly in geostrophic balance. Okay, now there is a way actually to, do this yourself. You can try to do it yourself if you like. I do have a slide, I think, later on here that you can do it if you like. But basically, we have, the wind, or the high pressure is going to be over here, where low pressure is going to be over here. We know that because we're looking at the millibars. So 1008 is greater than 1004, which is greater than 1000. So we know that this is lower pressure over here, and this is higher pressure over here. So because of that, we have the pressure gradient force going from high to low pressure. That's our vector. And then we have the Coriolis force, which is the exact opposite of that in equal force. So see how the arrows are the same length? Okay, and that's going to result in the wind actually being, is actually to the 90 degrees to the left of the Coriolis force. Yeah, Coriolis is to the right, or you could say that to the right of the motion, whichever way you decide that you want to kind of figure it out yourself. But, you know, if you think about it, that wind vector is always going to be, you know, parallel. So it's either going to be on this side or that side, right? So it's always, I always think of it to the left of the Coriolis force. So in this manner, we can always figure out actually which direction the winds are going in because we know which direction they're going to be moving in, or the force is going to pull it towards the low, and the Coriolis force is going to even it right back out again. All right, here's a weather map. I could pull up a current weather map if I wanted to right now. Almost all the time, I can think of very, very, very few instances where this actually wouldn't be the same. But, you know, aloft, when you're looking at, you know, 500 millibars, you know, you're looking like halfway through, you know, and up there to like 200 millibars, 300 millibars in the upper troposphere, you know, you actually can see how these wind bars are going to always flow parallel to the isobars. Pretty cool how it pretty much always works out that way. So you can just have the isobars here and have an idea as to which direction that wind is going to flow in. And these upper air winds that do flow parallel are called geostrophic winds. All right, now just some terminology so you guys kind of understand that. You know, you can see how right here where these isobars are kind of dipping down, we're going to refer to that as a trough. And where they're kind of coming up like, you know, like, I don't know, they're going to have a hump on it up here at the top. We're going to call that a ridge. So you can see how this would be a trough, and then it leads into a ridge, and then we have another trough right here. Okay? And this is going to be in the northern hemisphere. All right? I think I told you guys this at the beginning of this video, but you know, the low pressures are going to be called cyclones and the high pressures are going to be called anticyclones. So a lot of meteorologists will kind of use cyclonic flow or anticyclonic flow when they're talking about the actual wind or, you know, in the upper atmosphere. Okay, now we get to surface winds. Surface winds are, you know, we have the same exact forces going on to begin with. We have the pressure gradient force. So you can see here, the pressure gradient force is going to pull towards the low. The Coriolis force is going to even it out, be equal and opposite to the pressure gradient force, is going to pull the opposite way. And then that's going to cause the wind to be parallel to the isobars. Except for at the surface, we have one other force that kicks in, and that's friction. Because like we said, everything is down here at the surface. So friction is going to kick in and is actually going to kind of take the Coriolis force and just, it's going to slow it down so it kind of isn't as strong. Okay, and so it's just going to kind of make that vector kind of move over like by, you know, about 30 degrees. All right, so what the result of that is going to be, we're going to have this cyclonic flow going around the low down here at the surface, but it's actually going to kind of move inwards towards the low. You can kind of see how it's like moving inwards towards the low here. And it's going to do the opposite on the high. We have this anticyclonic flow on the high, but it's actually kind of moving out just a little bit. See how it kind of crosses over those isobars? Not at 90 degrees, but maybe at like 30 to 35 degrees. I think it says, yeah, 30 degrees right here in the book. Okay, so it's going to look kind of the same, but just a little bit different at the surface. It's just going to kind of be tweaked over just a little bit. Okay, here's another like kind of like to show this to you. Here's the pressure gradient force going from high to low pressure. We have the Coriolis force being on the other side, equal and opposite. And then 90 degrees to the Coriolis force, we're going to have the wind, which is geostrophic flow. Now remember, at the surface, that friction vector is going to kick in, all right? And it's going to slow down the wind. It's going to, so because it's slower, the Coriolis force isn't as strong. So see how that vector, see how it's longer there and it's like shorter here? Because it's not as strong. And because the Coriolis force is not as strong, that means the pressure gradient force is actually going to win. If it's kind of like a tug of war on this parcel of air, And the Coriolis force actually becomes weaker because of the friction, and so that means the pressure gradient force is going to win, and it's going to pull the airflow towards its side a little bit, which is why I see it's just kind of moves over a little bit by 30 degrees over here over these lines. Now remember, this is only at the surface because aloft we're in balance. All right, here's some other, depictions of it, and you can see, if there's a stronger pressure gradient force, the pressure gradient force is going to be stronger. The Coriolis force will still kind of, if this is at the surface, which it would have to be, yeah, at the surface, it's still gonna be there, but it just won't be as strong. Okay, now what does this mean? This whole area where it's kind of moving in under the cyclonic flow and it's kind of moving out a little bit during the anticyclonic flow is it means we actually have convergence and divergence. And if we go all the way back to, I don't know, a couple of weeks ago when we were talking about convergence and divergence and had that being like a lifting mechanism, okay, something that would nudge the air up when we're talking about stability. Okay, so if we have this air kind of moving in towards the surface, then that means that we're having convergence over a low pressure system. Well, the air can't go down, so it's got to go up, which means that we're going to have rising air over a low pressure system, and we're going to have sinking air because divergence is going to be happening over the high pressure system. All this air is going to rush in order to replace it. So then we're going to have sinking air over the high pressure system, okay, with the opposite aloft. Right? If we have divergence at the surface, then that means we're having convergence aloft. If we're having convergence at the surface, then we're having divergence aloft. But what this really comes down to is we're going to have this rising air over this low pressure system, and rising air always means that it can get, that air is going to get cooler as it's rising, and it's going to get closer to its dew point and possibly hit saturation, and then we're going to start seeing clouds and possibly some weather along with that. Sinking air over a high pressure system is going to generally be, associated with clear air, no clouds, sunny skies, things like that. Okay, so I'm kind of giving you guys the reason why, you'll see a lot of the times with these low pressure systems, for instance, one is actually going through our area right now, and you guys have noticed that we've had rain over the last few days. Well, the reason why is we have a low pressure system going through the area. Okay, we're kind of like on this side of the low pressure system, so it's bringing this moist air up from the south, and it's actually causing and it's also having some rising associated with it as well, which is actually giving us this cloudiness and the rain that we've been having over the last few days. Kind of cool how it works out like that. All right, this is the one I was telling you guys about. If you want to practice, if you're in class with me, I always have, some class time set aside, and we kind of go through some weather maps, and we kind of do some fun stuff like that. Unfortunately, we're not going to be able to do that this time around. So if you guys want to practice doing that, you can always just draw like an L and an H on a piece of paper and draw some lines down it, and you can kind of practice around with vectors. But as far as this week's lectures, this is the end of it. So I hope you guys are having a good week. Please get a hold of me if there's anything that you need. I'm hoping that going online hasn't been difficult for too many of you. And those of you that already have me online, well, lucky for you, I guess nothing has really changed. So I will see you guys after spring break. Thanks. Hope all is well.